Thank you for joining this lesson. We're going to look at the Kcse 2021 Mathematics Paper 2, Longitudes and Latitudes question. This is going to be in session 2, number 20. Whereby the question is telling us that an aircraft took off from point A, x degrees north, 15 degrees in the east, at 7:20 a.m. or rather 07:20 hours local time. It flew due west to another point, x degrees north, 75 in the west, a distance of 5,005 kilometers from A. After a stopover of 1 hour 30 minutes at B, the aircraft took off and flew for 3 hours 40 minutes due south to a point C. The aircraft maintained an average speed of 910 kilometers per hour for the journey from A to B and also from B to C. Take the pi as 22 out of 7 and radius of the Earth to be 6370 kilometers. Calculate the part 1 position of B. Now we're having the distance from A to B given, and we are given the positions of both A and B without the latitude. Therefore, we can obtain this latitude. Let's consider the kind of a distance it is from A to B. Remember, this is 0 degrees equator. This is the prime meridian, 0 degrees. Therefore, we are going to have A 0, some degrees in the north, which is x. This is x degrees in the north. Then 15 in the east. 15 degrees in the east. So this is A, 15 in the east. Then we have B, 75 in the west. So in the west, we have 75 here. 75 in the west. This is B. Therefore, now we are given the distance, but we are not given the positions. Therefore, we will say distance along a small circle in kilometers. Distance along a small circle in kilometers is given by theta over 360 2 pi r cosine of the latitude where the two places are. Theta is difference in longitudes. This is the cosine of the latitude where the two places lie. So now we have the distance already as 5,005 equals to theta, longitude difference from 15 in the east to 75 in the west. We will have 90 degrees out of 360 times 2 times pi times r, 6370, then cosine of their known latitude. So for us to remain with the cosine of their known latitude, then I think we should multiply 5,005 with 360 with also 7. Then we divide by 90 times 2 times 22 times 6370, so that we get cosine of the latitude at 0.5. So that the latitude is gotten by the cos inverse of 0.5. This is going to give us 60 degrees. If it is 60 degrees and it has been specified that it is to the north, then the position of B is going to be 60 degrees in the north, and we can see that B is also at 75 in the west. So 60 north, 75 in the west. Part 2 of the question, position of C. For us to get position of C, we should first of all get the distance. Remember, we are told from B, the aircraft took off and flew for 3 hours 40 minutes due south to C. Therefore, due south to C. C is at a place we don't know, but we can get the latitude difference between B and C by first of all saying the time is equal to 3 hours 40 minutes. We make them hours. This is going to give us 2/3, 3 and 2/3 of hours, which is going to be 11 out of 3 hours. Therefore, now if we have the time and we also have the speed, then we can get distance. Speed times time. So 910 times 11 out of 3, 11 out of 3, which is going to give us a 3,336 and 2/3 kilometers. And 2/3 kilometers. So if we have the distance, then we can get a formula which gives us distance along a great circle. In this case, we shall have this distance of 3,336 and 2/3 kilometers equals to the unknown liter out of 360 times 2 times pi times 6370, because along a great circle, liter over 360 2 pi r is the formula for distance. So now we can get liter, the angle difference, or rather the longitude, the latitude difference between B and C, now that we have the distance. So we multiply that distance with 360, we also multiply it with 7, then we divide with 2 by 22 by 6370. This is going to give us exactly 30 degrees. Therefore, the angle difference between B and C is 30 degrees. Remember, we are moving from 60 degrees north through an angle difference of 30, which means we are not past the equator. We are not past the equator, 0 degrees. So we are not in the southern hemisphere. We are still in the northern hemisphere, and we've narrowed down 30 degrees and we were at 60. So which means we are now at 30 degrees, but still in the north. Therefore, C is going to be 30 degrees north. Remember, we were moving along 75 degrees in the west. So this is going to be the position of C in the Earth's surface. Finally, we have part B. Determine the local time at point C when the aircraft arrived. At the beginning, it was 0720 hours. But now we have taken some time. We've taken some time whereby we can say the time traveled from A to B is going to be the distance divided by the speed. When we take 5,005, we divide by 910. This is going to be 5 hours, 30 minutes. Then there was a stoppage at B, which took 1 hour 30 minutes. 1 hour 30 minutes. Then we have from C to B. Okay, from B to C. From B to C. The journey took from B to C. Flew for 3 hours 40 minutes. 3 hours 40 minutes. So the total time of traveling is going to be, this is 1 hour 40 minutes, or 40. We're carrying an hour. 5, 6, 7. So we have 10 hours 40 minutes. Remember, it was 0720. We are now adding 10 hours 40 minutes, which is going to give us 0 we get 60 minutes. So we carry the whole hour, so that we have this one as 18 hours. Now that it is 18 hours, this is the time at A when the aircraft was beginning the journey. We should take into account that the time at B and C is different from the time at A. Therefore, when it was 0720 in the east, that was at A, time in the west was behind, and we saw that the longitude difference between A and B is 90. We know that for every 1 degree there is a 4 minutes time difference, which means for 90 minutes, for 90 degrees we have 4 by 90, giving us 360 minutes. 360 minutes translates to 6 hours. That is an indication that B and C are behind by 360 minutes. So which means the time we are getting here, we will subtract 6 hours, so that we arrive at 1200 hours. Because we were moving to the west, then time has to be behind by those hours. Thank you for following. Subscribe and share.